Welcome to a second example of using the reduction of order shortcut formula in order to find a second solution and the general solution to a linear second order homogeneous differential equation. In order to apply the shortcut formula, our differential equation must be in this form here. Notice how the coefficient of y double prime must be 1. Next, in order to apply the shortcut formula and the reduction of order method, we do have to be given one solution to the differential equation, which we'll call y sub 1 of x. So if the differential equation is in this form, and we're given y sub 1 of x, one solution, we can find a second solution, y sub 2 of x, using this formula here. Notice this integral here does involve p of x, which will be the coefficient of the y prime term. Let's take a look at our example. The first thing we should notice is that the given differential equation is not in the correct form in order to use the shortcut formula. So we want the first term to be y double prime, so we'll start by dividing everything by x squared. So this would give us a differential equation y double prime. This would be plus 3 divided by x times y prime. And let's write this as plus 1 divided by x squared times y equals 0. Notice in this form, we should recognize that p of x, the coefficient of y prime, would be 3 divided by x. And now we can go ahead and apply the shortcut formula given here. We would have y sub 2 of x. I'm going to go and just write y of x is equal to y sub 1 of x, which is given x to the power of negative 1, times the integral, and we have a fraction. The numerator is e raised to the power of negative the integral of p of x dx, so we would have negative integral 3 divided by x dx divided by y sub 1 of x squared. X to the negative 1 squared would be x to the negative 2, integrated with respect to x. Now for the first step, let's focus on this integral here. This would be negative 3 natural log x plus a constant c. So now we have x to the power of negative 1 times the integral of e raised to the power of negative 3 natural log x plus a constant c. Now looking at this natural log here, we're actually going to take this coefficient of negative 3 and move it to the position of the exponent before we simplify. This is still divided by x to the power of negative 2 dx. So this is going to be e raised to the power of natural log x to the negative 3. Then because we're adding the exponents, this would be the same as times e to the power of c divided by x to the power of negative 2. Let's go ahead and take this on to the next slide. E raised to the power of natural log x to the negative 3 simplifies nicely to x to the power of negative 3, and then e to the c is just another constant, which we'll call c sub 2. So now we have x to the negative 1 times the integral of, again, c sub 2 x to the power of negative 3 divided by x to the power of negative 2 dx. Now we'll simplify this, subtracting the exponents. Negative 3 minus negative 2 would be negative 1. So now we have x to the negative 1 times the integral of c sub 2 x to the negative 1, or c sub 2 divided by x dx. And now we'll integrate this. So we have x to the negative 1 times, this would be c sub 2 natural log x plus another constant, which we'll call c sub 1. So now notice when we distribute, this is actually going to give us the general solution because we'll have a sum of multiples of two linear independent functions. So y of x is equal to c sub 2 natural log x times x to the negative 1, or c sub 2 natural log x divided by x, and then plus c sub 1 x to the negative 1 or c sub 1 divided by x. Notice how this general solution does include the given solution when c sub 1 is equal to 1 and c sub 2 equals 0. So to find a second solution, which we'll call y sub 2 of x, we can go ahead and let c sub 1 equals 0 and c sub 2 equals 1. So a possible second solution would be y sub 2 of x equals natural log x divided by x. And that's going to do it for this example. I hope you found this helpful.